Good morning, good morning. Calculus BC. How you guys doing? All right, if you're here, go ahead and type in the chat so I know. Looks like maybe one person's here. Two people maybe? Good morning, good morning. Morning, Liberty. All right, there we go. How you doing, Liberty? You having a good morning? Happy Wednesday. What's today, the 6th? Man, time's flying. Pretty much this week and then next week you guys got your AP stuff. Except for, I think, stats is probably the only one you're not taking next week. So you probably won't do stats until, I think, stats like the 17th, right? Crazy. Pretty good so far, lots of coffee. You been up for a while, Liberty? Or you just wake up just tired? I was telling, oh, good morning, Rachel. I was telling my Algebra 2 class, every day, I mean, you guys saw probably, every day I drank coffee too, so I'd bring in a cup of coffee. And when we were at school, but now I'm kind of trying not to as much. Because, I mean, it's not really sleeping in, but, sleeping in till like 8:20 on the days I'm streaming is doing fine. Like, I can manage with that. So I've been trying not to drink coffee. Just think it's probably, I just feel better when I don't drink coffee. We got up like 20 minutes ago. Okay. Are we done with class after AP test? I can talk about that. Yeah. So I mean, things are a little bit up in the air right now. It's a little confusing, but here's what it sounds like is happening. So it sounds like starting on May 22nd. I think 22nd. That sounds right. 20th, 22nd, somewhere like around that time. School kind of is done. School's kind of over. I know we end June, whatever, but school is going to be done then. I think for seniors anyways, obviously it's my first year teaching, so I'm not sure, but I got to imagine you guys end school early anyways. If we were actually in school, I'm pretty sure seniors are on field trips a lot, and I don't know. I remember when I was in high school, like I literally got done before everyone else. Like we were done like a week or two ahead of everyone else. I don't know if that's the same thing at Vermilion or if that's how you guys do it, but regardless of any of that, you guys, especially like you two for sure, anyone in this class, anyone in BC will be done the 22nd or 20th, so I can't remember which one. And the rest of the time until the end of the year will be used as what they're calling remediation. I don't know if they're going to tell you guys or if they're going to email you guys or how that's going to get told to everyone, but the point of remediation is just for the kids who have 60, or no, I think it's even less than that, like a 40% or below in a class. They have to go through like remediation, meaning the teachers, myself, will have to take those kids and provide them extra review, provide them extra assignments, whatever, to make sure that they master the skills they need to master. That's essentially what remediation is going to be. Clearly, you guys are fine. I think you two, have 99% in the class, so you do all your assignments, you get everything done, that'd be no issue. So, moral of the story is, you guys, your school year is probably going to end pretty soon. Like 5 days after stats, which means I don't know what Mr. Snook's going to do after his stats AP test, but in terms of me, let me address what I'm sure you're more concerned about. I mean, that might be a good piece of information for you to have, but even more concerning probably is you're asking me when you're done with the AP test, am I going to give you any more stuff? Well, no, you're not done with the class, but I don't know how I can put this. Whatever we do is not going to be very much work and very much effort, I guess, if that makes sense. To be honest, I don't know. I have ideas of what I want to do. My main goal is to not stress you out, first of all, because I understand you have other AP tests, number one. And so, like, for example, next week, I'm not going to, after Monday, you guys are done with BC for that week. I'm going to give you the rest of the week. You guys can study for, I think, what else do you have? Maybe English and I know you at least have physics. So I'm going to give you the rest of the week. Just prepare for that. Just don't even worry about calculus. And then starting the following Monday, which would be what day? Let me think. That's going to be the 18th. So, like, basically we're going to have 1 week, I think, of where we'll have work to do. And it's just, I don't even know if I'm going to stream, to be honest. Maybe I'll do a stream just like for fun or something, but what I'm thinking about doing is maybe just giving you like a little article. I'm thinking maybe about like differential equations, something along that line, and then maybe a tiny little, I don't want to say project, because I want you to think like it's going to be like a huge thing. Like just maybe like a tiny little write-up or, activity. Something like that. That's what the plan is. Nothing that's going to, I'm hoping something that interests you, something that'll be interesting. Nothing that stresses you out, nothing that's going to put, a ton on your mind. Because I also know, obviously, you have that stats test that week. So, what is that? So, what day is the stats test? Maybe you guys know this. What day is the stats one? Is that I thought it was the 17th. But if I'm figuring this out, that doesn't make sense. Unless they're going to give it to you on a Sunday. I don't think they would do that. Maybe they would. I don't know. It's online, so it doesn't really matter what day of the week. $22nd. Oh, geez. Okay. So that's even later than I thought. Man, I don't know, why does the stats test so much later? Okay, that makes more sense though. 22nd makes more sense. Yeah, so I don't know. I'm 2 weeks from Friday. Jeez, okay. So that's probably gonna be the last day of school for you guys. So yeah, honestly then we're gonna have, after next Monday, we're gonna probably only have like two more streams. Or I don't even know if I'll do a stream. We're gonna have like basically a few days of BC stuff. So to answer your question, no, we're not going to do much. Class isn't over, but I might give like a little assignment. That's it. All right. Good question though. So, I do want to say you guys did a fantastic job on the 2018 FRQ. I commented on that. I know you two specifically got everything was perfect. To be honest, it was like very, very good. I don't even know. Obviously, I took, some of it was completion, the rest of it was accuracy, and I graded it just like AP gives me the outline to grade. And since there's only 4 of you, I'm usually pretty careful and pretty critical. Obviously the goal being to prepare you for next Tuesday and give you a good feedback. And you guys really, I don't think, you didn't miss a single point. It was awesome work. So that made me feel good. I hope that makes you feel good and confident and ready to go for next week. I really think you guys are going to kill it. So that was awesome. Keep that up. Think of it as like, you got 1 more week. For a lot of your classes, you got 1 more week and then you're basically done. So yeah, awesome job. Today, I'm going to start with, I'll review 2016. I can't remember what I got through on Monday. Because I think, I'm pretty sure, I don't even actually remember who was here. I don't know if both of you were here, if only maybe Rachel was. I can't remember. But FRQ question 1, I think we went over, if I'm not mistaken. FRQ question 3, I don't think we did. So if you guys remember, let me know. But I think all I need to review is 3. It was just you, Rachel. Okay. 1/1 on 2016. Okay. Liberty, I didn't wake up on time for Monday. Understood. You know, I don't. It doesn't bother me. This isn't mandatory. I'm surprised and I appreciate the fact that you guys do show up and actually communicate with me and don't just sit there and not comment or anything. So Liberty, if you want, you can have Rachel just text you a picture or tell you the answers for 1 if you haven't already. She should have all of them updated and everything. But I'll start on 3 then. So go ahead and get that out and type in the chat when you're good to go, ready to go. And I'll give you the answers to that. Yeah, Liberty, it'll be Monday. If I had to imagine, it'd probably be like right at the end of class, like right before the 1 hour mark. We probably went over it. So what was that? The 5-4 stream in YouTube. That'll be the video. Oh yeah, I didn't even realize I didn't even recommend that. I put the burden on Rachel. I said, Rachel, I'll get you the answers. Sorry, Rachel, for putting you in that position. Liberty, yes, you can watch the video that I carefully made on Monday to also get the answers. Really? Okay, I tried to check it out on Monday, but I don't think you had. Oh, okay, maybe like I hadn't posted it yet. Yeah, that is a good possibility of that. Hopefully, I posted my YouTube. I used to check them all the time to see if they posted. Now I haven't really been doing that. I don't even know really who watches them, but I know for like cases like this, it's really useful. Plus, it's not any extra effort for me to do. I just have to end the stream and just put some comments and then upload it. So I don't mind doing it. And the way I see it is like next year, if anyone needs like extra help or I don't like give an assignment, I don't feel like going over it, I can just be like, check out the YouTube video. I'll do it for you. So it's kind of win-win for me. Anyways, number 3. Rachel said she's good. Liberty, I'm assuming you got it out too. Where are the guys, by the way? I don't know if you talk to them very often, but I haven't seen Cole in a long time. And Hunter usually was here, and I haven't heard it from him in a while either. It's probably because they're staying up till 6 in the morning playing Fortnite or something. Okay. 3A. Let's start there. Let me get the assignment open. Okay. So 3. We skipped 2. 2 was vector. Girls rule, boys drew. That's the truth, Liberty. I'm going to be honest. I think I have a much higher percentage of girls that tune into the stream trying to put in extra work than guys do. Lazy video game players. Okay, so this question has a graph of f. They give g, which is defined by the integral from 2 to x of f of t. Okay, so that's the information you're given. Part A says, does g have relative minimum, max, or neither at x equals 10? So what you wanted to do was, whenever you're looking for a relative minimum and maximum, you need to take a derivative to find a critical point, and then look at the signs. So you find your critical point. G prime of x is just equal to f of x by the fundamental theorem of calculus. So all you're looking for part A is where does f of x equal 0? And where does f of x change sign? So f of x actually it just asks at 10. So at 10, you can see that there is a critical point, but at that critical point, it's constantly negative from the left and the right. So it stays negative, it keeps decreasing. That means there's neither a minimum or a maximum. So your answer for A was neither. Justification is just the fact that it doesn't change sign at x equals 10. Okay, for part B, point of inflection, we're looking at second derivative and concavity. Concavity, the definition of inflection point is when concavity changes from positive to negative or negative to positive. So you take the second derivative of g, which is equal to the first derivative of f. Set that equal to 0. This one specifically says that x equals 4. So that means we're basically just checking is f prime of 4 equal to 0. So you go to that on the graph, you can see there's a slope. The tangent line slope is 0 at that point. Okay, so more importantly though, at that point, does f prime of x change sign? So does the slope change? Yes, the slope does change. It's a positive slope to the left of it and a negative slope to the right of it. So yes, there's a point of inflection. You could say f prime of x changes signs at x equals 4 as your justification. Part C is absolute minimums and maximums. To find absolute minimums and maximums, we should be thinking candidates test, which means we need to find every critical point and the endpoints. We know the endpoints are negative 4 and 12, so we definitely have to keep those in mind. And then we got to find all the critical points by setting f of x equal to 0. You find that it's equal to negative 2 and 6. We're excluding 2 and 10 because you can see at x equals 2 and x equals 10, the sign doesn't change. So those can't be minimums or maximums. Because at 2, it just keeps increasing. At 10, it keeps decreasing. So eliminate those. We're not worried about them. All we're focused on is negative 4, which is an endpoint, negative 2, which is a critical point, 6, which is a critical point, and 12, which is an endpoint. In order to find which one's the absolute minimum and absolute maximum, you needed to find g of negative 4, g of negative 2, g of 6, and g of 12. So you're plugging in all those values for the integral, and then just solving. So you're going to have to find manual areas of triangles. So each one of these is split up into triangles. Remember, if it's below the x-axis, it's negative. If it's above the x-axis, it's positive. So you're just going to go through and find each area of each of those triangles, which I believe is pretty much, they're all pretty much equal. You just said whether they're positive or negative, and then 2 of them are half triangles. So you do that and you find that at negative 2 is a minimum point, absolute minimum. At 6 is an absolute maximum. Okay, and then the last part is part D. For negative 4 to 12, find all the intervals for which g of x is less than or equal to 0. Well, g of x is less than or equal to 0 occurs when the integral from 2 to x of f of t is less than or equal to 0. So all we're looking for is where on that graph, like what triangles are going to add to a negative number. So we kind of just have to go through and just pick intervals, like just pick some numbers. And you end up finding that's from negative 4 to 2. You're going to get a negative integral there, or a negative area. And then from 10 to 12, you get a negative area. And that's it. So any questions on 3, go ahead and ask them. I can talk about it. And if not, you guys are good to move on to 4 and 5. That one's really easy. I'll get okay, perfect. I'm glad you said that, Liberty and Rachel, because like from personally looking at this problem, this seems like a problem I could see being put on the AP test. This is a type of problem I could see because it includes an integral, it includes derivatives, it includes applying derivatives and applying integrals and like understanding what they all mean. So like this question kind of puts a ton of information from calculus all into one problem. So if you feel really good about this, that's good. It's a good sign. So yeah, go ahead then. You guys are good to get started on 4. 4's got a little bit of work. It's got work, but it's not like, I wouldn't say it's like crazy difficult work, but it does have a little bit of work. And then 5 would be very quick if you had a calculator. Technically, you're not supposed to have them, so try not to use them for these problems, just for good practice. But to check your work, you're more than welcome to use a calculator. Oh, and also before I forget, if you guys can post your 2019 FRQ, International Practice FRQ. If you guys can submit your work for that, if you haven't already, please do that, so I can eventually get to grading that. My goal. It's been honestly painful because I've had to do your classes and AB, and I didn't realize how long these took to grade. Like by actually looking at everyone's work and like grading it for accuracy, it takes forever. So I mean, I feel like you might think that I'm behind on grading and stuff, but I'm trying to stay up on it. It takes a long time, but I want to give you feedback before the test. So I'm trying to grade them all. So if you guys can submit that, I'll get it done for you so you can look it over. Even though we do mostly go over the stuff, so at least you have the answers for the most part. Sorry to interrupt you guys. I can't remember. Do you guys have a AP test Monday by any chance? No, no. Okay, cool. Tuesday, Wednesday, Thursday. Oh, geez. Okay. Do we have an integral for part B? No, you should not have an integral for part B. If you want me to go into more detail than that, I can be more than happy to, but I guess to clarify, Liberty, the reason why we don't have an integral for part B is because f of x is a solution to the derivative. So that means that, and we're looking at f, so if we want to find relative min or max, we just want to take the derivative. And we're given the derivative, which is kind of nice. So it makes our life even easier. So in order to find if that's a minimum or maximum, we're going to have to do a little bit more, I guess. Yep. So exactly, Liberty. So you'll take the first derivative. The first derivative will just check to see if it's a critical point, which it turns out that it is. So all you'll do is you'll plug in -2 and 8 into the derivative. In order to determine if that critical point is a min or max, we got to see if concavity, or what concavity is, and that's called the second derivative test. So second derivative test says if you can find the derivative is equal to 0, and then if the second derivative is greater than 0, it's going to be concave up, meaning that's going to be a relative minimum. And if your second derivative is less than 0, it's going to be a relative maximum. So you have to find the second derivative, and then you have to plug, well, you already did find the second derivative in part A, and then all you have to do is you plug in the point -2, 8, find if it's positive or negative. If you want me to put it on paper, by the way, I can do that too. So. Okay, cool. No problem. That makes sense. Yeah, I remember. I think earlier in the year, or earlier, like in like a couple weeks ago, I think we did a problem like this, and I noticed that everyone understood what they were doing, but they didn't, like you said, justify it with the second derivative test. So that's something. Make sure you guys, if you guys are using your cheat sheet or however you're studying or preparing for, make sure you mark that down somewhere because that is a really useful tool for justification. Did you say we could use our calculator for 5? There's some gross math here. Okay, so I think I would like you to try not to. I would like you to use your. I know there is, Rachel, and you're supposed to, because this is a non-calculator portion. Obviously, for your real AP test, you'll have a calculator, so I'm not super concerned. I would like you guys, especially because we got about 18 minutes left. I would like you to challenge yourselves to finding the answer. Here's what I'll say, Rachel. How about this? You can use your calculator to plug in numbers, but don't just use your calculator to get the entire integral. How about that? So use your calculator once you get to the point where the integral's gone. You took the general antiderivative. There you go. There's your answer. And then when it comes to actually evaluating the general antiderivative at whatever bounds, then you can use your calculator to do that. Yeah. So guys, about probably like 9:55. I'll go over the answers for these. So even if you don't have the answers to 5 completely done yet, it sounds like 4 is probably okay. Even if you don't have all the answers, this way you can at least write them down so you know what you're supposed to get to. So about 3 minutes, I'll start doing that. Part C of 5, so almost. Okay, cool. All right, cool. Rachel's good. Liberty, where are you at? You almost done? Ready? Okay, cool. All right, so first question for number 4A. So 4A, you said to take the second derivative using implicit differentiation. And your final answer should have been something like this: 2x minus 1/2 x squared plus 1/4 y. 2x minus 1/2 x squared plus 1/4 y. Part B, we kind of already went over. You want to take the first derivative, show that at negative 2, 8 equals 0, which it does. Then take the second derivative at negative 2, 8, and you find that you get negative 4. And negative 4 is negative. So you have a critical point with a concave down, or you have a critical point that is concave down, meaning it has to be a relative maximum point. By the second derivative test is your justification. For part C, use L'Hopital's twice, actually. So your first time you direct sub negative 1, you get indeterminate. Second time you do L'Hopital's, you sub negative 1, you get indeterminate again. And then the third time you do L'Hopital's, you should get negative 1/3. So 4C is negative 1/3. 4D was using Euler's method. So your step size is 1/2. So you should be x sub 0 is 0, x sub 1 is 1/2, x sub 2 is 1. You do Euler's method, go through that process, and you should get h of 1 is approximately 5/4. Again, h of 1 is approximately 5/4. All right, so number 5, we have this funnel. We're given the radius, what the radius equals at a height h. That's all the information we're given. So the first question says to find the average value of the radius. To find an average value, we're just using an average value formula, which is 1 over b minus a. In other words, 1 over 10 minus 0, because it says that h is between 0 and 10. So that's how we know our bounds. So you get 1/10 times the integral from 0 to 10 of your function for the radius, which is 1 over 20 times 3 plus h squared. Okay, you get that integral. Those are, so what you want to do on the inside of the integral, if you didn't use your calculator, what you wanted to do was distribute the 1 over 20. After you distribute the 1 over 20, then it's just general antiderivative. So it's like basic antiderivatives. It's the reverse power rule. So you reverse power rule them, evaluate them from 10 to 0. Plug that in, you get 109 divided by 60. So 5a is 109 divided by 60. For 5b, it says find the volume of the funnel. So if we're finding a volume, we want to be using reflecting it across, or that's when you cut something horizontally with horizontal cross section or vertical cross sections. However, the question asks. This one just says to find the volume. So your method was just the disk method. The disk method is always the method we try to use when it's asking us for volumes of 3D shapes. So we use disk method, which is pi times the integral from 0 to 10 of radius squared, or your function squared. Same idea here. You're going to want to distribute the 1 over 20, and then you want to square whatever's left over. So you're going to have 3 over 20 plus 1 over 20 h squared. Square that whole thing to get them all the parts spread out, and then that's just a general antiderivative after that. Plug in 10 and 0. 0 is going to cancel everything out, which is kind of nice. So really you're just plugging in 10. And you end up getting 2,209 pi divided by 40. Again, 2,209 pi divided by 40. And then the last part C, says what is the rate of change of the height? First thing we need to know is understand that we're only given one equation, r. So based off of r, if we're looking for the rate of change of height, that's equal to h prime. So we're looking for h prime. We're given r. We're given r prime because it says that the radius of the surface of the liquid is decreasing at a rate of 1/5. So r prime is negative 1/5. We're given h. It says h equals 3. So we have all the pieces we need. We just have to take a derivative of r, which you get r prime equals 1/10 h times h prime. And then plug in what we know and solve for h prime. And you end up getting negative 2/3 inches per second. Again, C is negative 2/3 inches per second. And that's the assignment. That's 4 and 5. 6 for homework. And for 6, you don't have to do part D. So 6, you just have to do A through C. So it shouldn't take you very long. Number 6 should be pretty quick. All right, BC, that marks the end of today's assignment. As always, I'll be here Friday, so you guys want to pop in on Friday. I'll go over any questions you have. I'll go over number 6, and then you guys will be good. Yeah, no problem, Rachel. Have a fantastic day, you too. Hopefully see you Friday. Talk to you Friday. Yep, no problem, Liberty. Good morning, AB. How are you guys? Yeah, I'll show you my face. Good morning, good morning, good morning. Morning, Stacklin. So you guys can go ahead, while I'm waiting, I'll give it, as always, give about 4 minutes. Go ahead and get your 2018 FRQ open. We'll be working exclusively in that today. Good morning, Jasmine. So have that open, ready to go. Good morning, Digidio. How's everyone doing? Happy hump day. Today is the 6th. Time is flying by. You guys don't have that much time left. So I don't know if I told you guys this before, but I'm not much of a breakfast eater, so I usually don't eat breakfast, which is probably stupid. I understand that. I don't know why. I think when I was little, I used to like not. I used to get like sick when I ate breakfast. I didn't feel very good, and I think that's kind of scarred me ever since. I don't hate breakfast food. I don't mind it. I just like I don't know. When I wake up in the morning, I just don't feel like eating anything. Drink a lot of water, but I don't feel like eating anything. So I usually for breakfast I'll wait a little bit and then I'll eat like a protein bar or something to tie me over. Anyways, why am I saying this? Well, yesterday I woke up and I felt motivated for whatever reason. I actually made myself some breakfast. So I made some sunny side up eggs, some toast, some buttered toast. Had some fresh fruit. It was pretty good. It was a nice little treat for myself. Alexis, Brand, you guys are both the same way. I don't recommend it. Listen, yeah, I don't think it's good. Like I'm not gonna tell people like, yeah, it's life changing or it's a good idea. I don't choose to do it. Like I just don't feel like eating in the morning. I'm just not. That's not the first thing I want to do. Like I just slept. I'm tired. I don't want to just make like myself a 3-course meal with sausage, bacon, egg. Like I don't know how people do it, but some people love breakfast. I'm like, geez, my stomach needs to just get accustomed to the day. I need something in me to jumpstart it, but like I don't know if I eat a ton of food, I'm just gonna be groggy and tired. It doesn't give me like energy to do the rest. I don't know. That's my way to look at it. And he says I don't usually eat till like 2 or 3. Now, yeah, see, I try not to wait till 2 or 3. Like, luckily with this stream setup we have, I get to eat lunch at like 12 o'clock, which is nice. That gives me that's like perfect time for me. And at school, I had lunch 6th period, which was fine. That's a fine time to eat. So 7th is a little late. 5 or 6 I'm fine with, but yeah, I like to eat early because obviously I don't eat breakfast, so I like to eat my lunch earlier. So I try to eat lunch before noon or before 1 at least. My breakfast is a monster. Yeah, that's what I'm talking about, Alexa. I don't know, like some people, if I eat like on a weekend, if I make myself breakfast after I sleep in, like have some time to like drink some coffee, orange juice, whatever, and then eat breakfast. Yeah, I make a huge breakfast. Brand, things taste different when you just wake up. Yeah, that's true. Yeah, it's like I don't know. My mind is just not ready to consume food. I don't wake up and it's like I need bacon. That's just not how my body works. I don't think. So I like to keep it easy, like a banana or like a nutrient bar or a protein bar, like Cliff Bar, something like that. Just like a quick energy booster. That's about it. Payne, there's a baby deer Jay chilling in my backyard. Aw, that's awesome. I love deer. Actually, I don't love deer. Deer kind of suck. If we really think about it, don't they suck? They do suck, but they're cute. Like a little baby deer, it's cute. There's way too many of them though, and they're dangerous. My cousin got in a car accident because of them. Not good. Just driving like a country road, and the country roads, you're flying. So just driving, minding his own business, and it was like night, so you can only see so much. You can't really see the sides of the roads on a country road. It's hard enough. You have to probably turn your brights on. Anyways, he's just driving, and a deer just flies in front of him. He hits it, and he like didn't know what hit him. He's like, it's craziness. And when you're going 60 miles per hour and a deer hits you, it's not like a casual thing. That's like it's pretty serious. Totaled his car. He was luckily okay. He was healthy, but still, I mean, one wrong hit, it's not good. That's the thing that I hate about driving. Is like there's so many. Driving's the most dangerous thing you'll do in your life, which is crazy because most people do it every single day. But it's the most dangerous thing. You're like, oh yeah, I'm a risk taker. I'm gonna go swim with sharks. I'm a risk taker. I'm gonna jump out a airplane and parachute down. All that stuff. You might think like, yeah, I'm definitely taking a risk. That's nothing. The chance of you surviving there are not even, or the chance of you not even getting hurt are pretty, very, very high for both of those, right? But the chance of you getting hurt in a car accident, I don't know. I mean, it's probably not a crazy percent considering, most people survive without ever having one, which is great. But the thing that sucks is everything's out of your control. You can't react quick enough if a deer comes flying across out of nowhere. You can't react to another person being an idiot. That's what freaks me out. People are idiots. You can't trust them. You're driving on a highway and someone just starts swerving your lanes. Nothing you can do about it. Didn't want to freak you out, guys, at 10 o'clock in the morning. Sorry. I just kind of where my head went. But driving, dangerous. Maybe that lecture will make you guys think twice. Maybe it makes you appreciate it more and take it more seriously and more controlled. Like, so I ran over a snake and oh wow, but it scared me so bad I can't imagine. Yeah, I mean even snake. I ran over I think it was like a raccoon or a possum or something. I don't know what it was, but I remember running over something and it was so weird because I didn't see it in my rearview mirror after I hit it. But yeah, those little critters. They don't really do too much to your car. It doesn't mess you up too much, but it's sad, you know. Like, geez, what did I just do? Speaking big facts. Yeah, I'm trying to, Brandon. Hit a groundhog last week. Hit a squirrel yesterday. Jeez, guys. His chat is full of animal. I don't want to say animal abusers. I wouldn't label you guys that. But jeez, how many animals are you guys? It's like you guys are trying to. Like you're getting points for hitting animals. That's crap. How's everyone hitting in like such a recent time too? Yeah, Brian, it's hard to avoid. Good luck. Knock on wood for sure, but yes, yeah, the groundhog can mess up your car. I think the raccoon I hit messed up a little bit. It wasn't too bad, but like the front fender was a little bit bent. And hitting a squirrel, still, even hitting a squirrel could do a little bit of damage, but you know what though? At the end of the day, here's more Mr. Harris advice for you guys. At the end of the day, if you see an animal that like skirts out in front of you when you're like driving, don't try to like this isn't great, but like it's worse if you try to like swerve out of the way. Because if you swerve out of the way, you could swerve into oncoming traffic, or you could swerve into a ditch or into the side of the road or hit a mailbox. Like there's a lot bad that could happen. So if it's like a split second decision, you have no choice, just hit the animal. I mean, it's messed up. It's better you pay for the damage of your car than pay for like hurting yourself, like your medical bills or another person. I ran a squirrel over on the way to school for again. Yeah, it's sad. They're stupid. Like, why are they running in traffic? But still, it's sad. You never want to hurt animals. Yeah, that's what I'm saying, Stack. Just hit it. A tree, yeah, a pole or a tree will be way worse. Pole will definitely total you. I mean, both will definitely total your car. Number one. More importantly, though, if you hit a squirrel or an animal, you personally aren't going to get your car might get messed up. You personally are probably going to be okay. Whereas if you hit a pole going full speed or a tree full speed, way worse for you. That can do damage. So moral of the story is don't aim for them, but if an animal gets in front of you, you got to do what you got to do on a road. Don't try to swerve out of the way. Especially if it's raining or snowing. Worst idea you can do. Just run right through it. Anyways, let's get back to being positive. I don't know how I got on that tangent. I hope you guys are all doing good. Oh, here, I gotta repaint. So I already hit a car and a guardrail, so it actually got cheaper and the groundhog did not cost me. Yeah, there you go. Jeez, Peyton. Looks like you've lived a life of car experiences. Not good. Good thing you're okay, though. All right, so 2018, FRQ. What I need to do, or what I'm going to do, is I'm going to go over your homework. I'm just going to give you the answers. So I'm going to tell you what the answers should be, and then you guys can check your work. Since I've kind of ranted a little bit, maybe I'll go over like a part of one. Yeah, maybe I'll go over part of one. Yeah, okay, Brandon. You keep thinking that way. All right, so FRQ 2018, let's start with number 1. Okay, so number 1, they give you this table. They ask you to fill it out. So your answer for 1A should have been 1.35. Your explanation is at time t equals 3 minutes, the rate at which grain is being added to the silo is increasing at a rate of 1.35 feet cubed per minute squared. All right, for part B, we want to write an integral that expresses the total amount of grain and then use the right Riemann sum to solve that. So your integral is 0 to 8 of g of t. That's the total amount of grain, because the rate of change of grain is g of t, so the total amount would just be the integral of g of t. To use the right Riemann sum, do that method, and then you get 160.8 feet cubed. Again, 1b is 160.8 feet cubed. 1c, you should have gotten 61.749 feet cubed. Again, 61.749 feet cubed. Big thing here, we already know the total amount of grain was 160.8. That's what we found in 1b. The amount of spoiled grain you find by taking the integral of w of t. So the integral from 0 to 8 of w of t, which is 99.05. So in order to find the unspoiled grain, you take the total amount of grain in general minus the amount spoiled will give you the amount of unspoiled. And that's 61.749 feet cubed. For part D, basically you're saying, okay, well, the rate of change of unspoiled grain, that's going to be basically a derivative, right? It's the derivative of unspoiled grain. So that means it's also going to be the derivative of the amount of spoiled and the amount of in general. In other words, all you're doing is you're finding g of 6 and w of 6. Because g of 6 represents the rate of change of the total amount of grain. W represents the rate of change of spoiled grain. Subtract those two and you end up getting a positive value, which means that the amount of unspoiled soil is increasing. If your derivative gives you a positive value, it means it's increasing. So for that question, no one needs to ask. I'm not going to do any of that now because I went over that actually. If you go to my YouTube page, I posted my office hours from Monday. So I went over this with Andrew and Haber. We went over that problem. So you guys can check that on Monday's office hour. So I posted that. Just fast forward, try to find it, and that'll give you step-by-step directions on if you struggled with C and D. Okay, 2. So 2, remember you're skipping part C for number 2. And 2 said they have the snail traveling along a straight path, and they're given a snail's velocity equation. So, first thing is to find acceleration. If you're finding acceleration, it's derivative of velocity. So you take the derivative of v of t, you plug in 5 for t, and you get 0.538 inches per minute squared. Again, 0.538 inches per minute squared. For 2b, it says what is displacement? You can find displacement, that's the same thing as position. That's an integral of velocity. So remember, to go from position to velocity, you take a derivative. To get from velocity back to position, you take an integral. So if we're finding displacement, we need to find where the position of the snail is. So you take the integral from 0 to 15 of v of t. Put that in your calculator, and you get 76.043 inches. The displacement of the snail is 76.043 inches. C we're skipping because we don't know how to find the average velocity. That's a Unit 8 topic. So we skip C. Although it would have been very easy for me to talk about, I just don't want to I don't want to add another thing to your brain that doesn't need to be added right now. So for D was kind of a little bit of a doozy. So there's a lot going on here. Basically, here's how we needed to solve this. So I'll talk about generally, what the steps are. So the ant's velocity is going to be the integral of the acceleration. So we need to find the ant's velocity. That's ultimately the question says to find B, which is the ant's velocity. That's what we're looking for. So to find the ant's velocity, you take the integral of acceleration. The acceleration is 2. That's what it says. It says the ant travels with a constant acceleration of 2. So you take the integral of 2 and you get 2t plus c. Because remember, this is a general antiderivative, the ant's velocity. So you get 2t plus c. Now we need to find c. We can't find what that equals. So we need to find t, which we know is 12. Or no, sorry. No. We need to find t. So we'll use that in a second. But more importantly, we need to get c. So we use ant's displacement. The ant's displacement is equal to the integral from 12 to 15 of the velocity. Right? We just talked about that in the last part. To find displacement, you take the integral of velocity. You do your math on that, you get 81 plus 3c. So the ant's velocity is 2t plus c. Ant's displacement is 81 plus 3c. And then from part B, we know the snail is at 76.043 inches at time t equals 15. That was our answer to part B. We got that. So all we're doing is we're taking the ant's displacement formula, 81 plus 3c, setting it equal to 76.043, solve for c, and you get c equals negative 1.652. So to find the ant's velocity, we take the formula 2t plus c. In this case, they want to know the ant's velocity at time t equals 12. So you plug in 12 for t, you plug in the c that we just found, and your final answer ends up being 22.345 inches per minute. Can we just do 2D? Yeah, that's fine. All right. So, 2D. A lot going on. It says where this ant arrives at the snail's starting position at t equals 12. During the interval 12 to 15, the ant travels in the same direction as the snail with a constant direction or acceleration of 2 inches per minute. The ant catches up to the snail at time t equals 15. The ant's velocity is b. Find the value of b. Okay, so we have b is equal to the ant's velocity, which is equal to. So in order to get to a velocity, we need to take the integral of an acceleration. Sorry. All right, there we go. So I wrote down some of this stuff. Okay, so b is equal to the ant's velocity, which we're ultimately looking for, and that's equal to the integral of acceleration. So you might be asking yourself, okay, Mr. Harris, shouldn't this give us like an answer like pretty easily? Because we know that a of t is equal to 2. So it says that the ant travels with a constant acceleration of 2. So maybe you guys are thinking, well, why isn't this bounded? Doesn't it say the interval 12 to 15? That's not the case. Because, first of all, the velocity is constantly changing. We need to find the velocity at a specific point. So if we can get a general equation that represents the velocity, like a general statement for velocity in that time frame, or in any time frame, because it's a constant velocity acceleration, then we're in good shape. So you take a derivative, or an integral, take an integral of 2, and you get 2t, but since it's indefinite, you have to add c. So the integral of 2 is 2t plus c. Now I know t is 12, so like that's good. Like t is 12, I would be fine with that. But I don't know c. I need to find c, and I need to specifically find c by taking the ant's displacement. So why do I know I need the displacement? What gives it away? Okay, so here's the key in how you can tell that the ant's displacement is what's going to be important. It's because it says the ant catches up to the snail at t equals 15. That's the giveaway. That sentence right there. The ant catches up to the snail. That means that at 15 minutes, the ant and the snail are next to each other. It means they're together. They have the same displacement. So we need to figure out the integral of velocity. In this case, we do have a definite integral, 12 to 15. We want to know from 12 minutes to 15 minutes, how far did the ant travel? Well, guess what else we know? We know what velocity is. So the integral from 12 to 15 of velocity, well, the ant's velocity is 2t plus c. So I just plug that in to my integral. The antiderivative of 2t is t squared. The antiderivative of a constant, let's just say it's 3. I don't care. It's a constant. say it's 3, let's say it's 4, let's say it's 5, whatever. If you're taking the antiderivative of that, it's going to be that constant times t. Between 12 and 15. Now you have your calculator, but in this case you don't want to use your calculator because you have that c. So what we're going to do is we're going to plug in 15 in for t. So we're going to get 15 squared plus 15c, that whole quantity minus 12 squared plus 12c. So I just plugged in 15 and then plugged in 12 and took the difference of those. That's the fundamental theorem of calculus. And to simplify that would be beneficial. You're going to get 81 plus 3c. So this displacement means at t equals 15, so the end of our interval, at t equals 15, after the ant traveled, the ants were marching 2 by 2, hurrah, they started traveling. At the time it equals 15, that ant was at 81.3 plus 3c inches. Okay, but we know at that time it was at the same place as the snail, which into B, we found where the snail was. It's 76.043. So that was from part B. Ant equals snail. Right? Ant's position equals the snail position. It told us that in the question. So that means if the ant or the snail was at 76.043 after 15 minutes, so should the ant. You solve for that, I'm not worried about that. You guys can figure that out. You get negative 1.652 equals C. So at t equals 12 then, I'm just going to do this. At t equals 12, b is going to be equal to 2 times t, which is 12, minus 1.652. Right, we're looking for b, which is the ant's velocity. So b is equal to that, which means b is equal to 22.345 inches per minute. And that's 2D. Hardest part of this question is not the calculus, it's the conceptual idea. So the actual calculus we did, a couple integrals, right? Some stuff can be difficult, like understanding that the integral of c is ct, little stuff like that. But for the most part, it's just understanding all the information they give us, breaking it down, and using it as all together. My recommendation, if you're stuck like this, to walk yourself through it, always first start with what do I need? And that's what I did, right? I started with velocity. I said, I need the velocity. That's the question. The question's asking for b, which is the ant's velocity. So let's think of a way I can represent the ant's velocity. What do I know? What don't I know? And go from there. You know, so they give us this acceleration. Every piece they give us in the problem, I've said this a million times, anything you're given in a college board question or AP question, you will have to use. They don't give you information for no reason. So sometimes they give you information that we can kind of like let it go. Like it's not going to be, it's good information to have, but we're not going to actually physically use it. But it's there for a reason. They never say anything to throw you off or just like to unnecessarily. They put stuff there for a reason. So if they're giving us the acceleration, we have to use it, and we'll go from there. And that's kind of the thought process you would take. Again, we knew ant's displacement was useful because it tells us the fact that the ant ends up the same spot as the snail, which is that's what displacement means. So we know we have to use that fact as well. All right. Cool. let's get started on number 3 then. So go ahead and get 3 out, guys. Show you on my computer what 3 looks like. So this was 3. And you know what? I'm going to let you guys do 3A. So you guys do 3A on your own. And then I want you to type your answers when you're done. So I'll be talking about the situation. You guys take a look at it too. We're given a graph of G. It's on an interval of -4 to 8. There's 2 linear pieces and a semicircle. Okay? Let f be the function defined by f of x equals 3x plus the integral from 0 to x of g of t. So we have this brand new function f. We don't have a graph of it. We just know that it's equal to 3x plus 0 to x of g of t. So we need to find f of 7 and f prime of 7. So the first one, you're just going to plug in 7 for x. The second one, you're going to need to find what the derivative of f is. All right, so go ahead and dive into that, guys. And then type your answers when you're done. All right, guys, about 2 more minutes, maybe less. Just start seeing some answers popping up. All right, that should be plenty of time for you guys, so let me go over this part. So we're breaking this down into 2 questions. All right, the first one is, what is f of 7? All right, well, if we're finding f of 7, then we're going to take the equation for f of x, and we're going to plug in 7. So that's going to be equal to 3 times 7 plus the integral from 0 to 7 of g of t. All right, well, 3 times 7 is 21 plus. What does that mean? So the only one I saw was Andrew's answer, and I think Andrew might have got a little confused with this second part. What did that mean? This whole square in the blue here, that statement is just saying what is the area underneath the curve of G from 0 to 7. What is the area under the curve of G from 0 to 7? So if I go to my problem, I'm looking, if I had a highlighter, I'd highlight it from 0 to 7. So I would shade in all of this area, shade, 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 and then this rectangle from 6 to 7, this tiny little rectangle here. I need to find the area of that whole section. So the first area is going to be the semicircle, which we can find by having negative 1/2 because it's below the x-axis. Negative 1/2 pi times r squared. And what's r? Well, the radius of the semicircle is 3. So 3 squared. So 21 plus negative 1/2 times pi times 3 squared. Plus, because the rectangle is above the x-axis. Am I still on my screen? Okay, you can still see me. This will be plus the area of this rectangle here, this little rectangle, the length is 1, height is 3. 3 times 1 is 3. So plus 3. So on your paper, you'll have this expression, 21 plus negative 1/2 times pi times 3 squared plus 3. Put that all together, and you get 24 minus 4.5 pi. Second one, we need to find f prime of 7. Well, first we need to find f prime of x. Can't find f prime of 7 without f prime of x. So we need to take the derivative of f, which means the derivative of 3x is 3. The derivative of the integral from 0 to x of g of t is going to be g of x. That's by the fundamental theorem of calculus. So that means that f prime of 7 is equal to 3 plus g of 7. To find g of 7, we just look at our graph, and it's at 3. So it's 3 plus 3 equals 6. So go ahead in the chat, let me know. Did you guys get that? Are you okay? Because I didn't get any comments. Okay, cool. Peyton understands. Makes sense now. Okay, cool. All right, so 3B. You know what? Let's do 3B too. I'll let you guys do this on your own. So the AP test is coming up. Why don't we let you guys do some stuff on your own? Okay, I'm going to give you till 10:41. So 3 minutes you have for this question. Find the value of x on the closed interval at which f attains a maximum. All right, that should have been enough time again. So make sure if you weren't there yet, probably a little slow. So try to work a little bit quicker. So the question says to find the value of x which attains a maximum value. You see the word maximum value, maximum point, relative max, absolute max, all of that stuff. We need to be thinking first derivative. So right off the bat, I need to write down the fact that the first derivative is equal to 3 plus g of x. Why do I need to know that? Because the first derivative gives me increasing or decreasing. In order for there to be a maximum value, I need to find where in the graph of f was it increasing and increasing specifically. That's where max value would occur. So this one's a little bit different because we're not like plugging anything in. I mean, we kind of are, but we're just checking, okay, from -4 to 3. Just on that interval, what's going on? Is there a critical point? What's happening? So I'm going to go over to my screen now. Let's look at my graph. So f prime of x is equal to, it's not going to let me. F prime of x is equal to 3 plus g of x. So what we want to figure out on the interval from -4 to 3, what is happening to g of x? Well, look at g of x from -4 to 3. G of x is 2, 1, 0, -1, -2, and then gets to -3. So think about that, guys. It means that whenever I'm plugging in for g of x, on that interval. Whenever I'm plugging in for this, it's always going to be a number that's less than 3. Right? 2 is less than 3, 1 is less than 3, 0 is less than 3, -2 is less than 3, and so on. Right? So it's always this value from -4 to 3, f prime of x is always going to be greater than 0. Because no matter what g of x is on that interval, this will never be a negative number because it's always going to be less than 3. So from -4 to 3, f prime of x is greater than 0. So f of x is always increasing. Meaning the max would occur at the endpoint. So it occurs at x equals 3. That would be your full answer. F prime of x equals 3 plus g of x. F prime of x will always be greater than 0, so it's always increasing. If the function is always increasing, the max point will occur just at the end, when that function stops increasing at the very end. In this case, it's the end of the interval. All right, how do we feel about that, people? Eh? Need more information than that to Gidio, you know that. You let me know what you need clarified if you need something clarified. All right, I'm not seeing. I appreciate the feedback though, Brian. I'm not seeing anyone else comment. So I guess I can take that as you're good. Not sure. If you guys need something to be reiterated, let me know though. And if I don't see any comments, then there you go. I don't know what I need clarified, to be honest. I didn't know how to start this problem. Okay, so biggest thing, Brandon, that's a good question. Maximum value. Like that's it. That word alone, those words alone mean you need a derivative. So that's how you know where to start. If we're looking for a maximum value of f, we need f prime. Don't need to think about anything else. So make a note for yourselves. Whenever you see the words maximum and minimum, you got to think first derivative. The function's f, so it's the first derivative of f. So we got to start there. To go from there, we want to find a max point. We should be finding critical points, right? So basically, when you set that, when is f prime of x equals 0? In this case, though, we don't have any spots that do that. So if we can't find any critical points to find the maximum value, we just got to see the behavior of the graph. If it's always decreasing, the first point will be the highest point. If it's always increasing, the last point will be the highest point. And that's what we found out. We found out that it was always increasing by just plugging in values of x. So you plug in -4, plug in -3, plug in -2, and you'll find what's happening to g. So that's as much as I can clarify about it. I think the tricky part of this question is it's not a calculus question. It's just I shouldn't say common sense, but it's just kind of just think about the problem, not from like a formula standpoint or anything else. Just think about it's a conceptual question, I guess. All right, so 3C, go ahead and start that. Um, 3 minutes, so 11 o'clock, or 10:50, you should be done. Probably shouldn't even really take you that long, but I'll give you till 10:50. Yeah, understood, Brandon. All right, so that should be enough time. So go ahead and check your work with me as I go. Okay, so the limit as x approaches 0 from the left, that's what that means. So this whole statement is saying the limit as x approaches 0 from the left of g prime of x. Well, remember, our graph that we're given is of g, not g prime. So what is g prime? What does the derivative of g represent? That's the slope of the tangent line. So this question equates to slope of tangent line from left, and then slope of tangent line from right. At the end of the day, that's what these questions are asking. That's all it is. The limit of those are just going to be what's the slope from the left and what's the slope from the right. Well, the slope of the left of 0 is easy because it's always the same. That's a line. It's linear. So the entire g prime of x to the left of 0 is always going to be whatever that slope is. So you use your slope triangle, however you find slope, and you end up getting negative 1/2. So if I were to draw the graph of g prime, that would just be a horizontal line at negative 1/2 up until 0. Right? And if we take that limit, of course, it's going to be approaching negative 1/2. From the right, it's a little bit trickier because notice that's a semicircle. So that graph is exponentially increasing and increasing and increasing until at the ends of the circle, of a semicircle, at the two ends, that's a vertical tangent line. So I can write vertical tangent line, which means the limit won't exist. A vertical tangent line doesn't have a slope. So from the right of 0, since there is no slope at that point, it's going to be does not exist. And this is why. So your justification will be vertical tangent line. All right, and then we're going to end with 3D. So go ahead and do 3D. I'll give you about 5 minutes. Please put your answer if you get one. So in the chat, please put what your answer is for 3D. I'll say this now just so you guys know. For homework, you're going to finish this assignment. So you're going to do 5 and 6. And I will go over them on Friday. So Friday I'll have the whole time. We can go in detail of all these questions. Yeah, Haver, you're skipping number 4. Correct. All right, guys, about a minute left. Yep, good job, Peyton. Yep, good job, Hayward. Awesome. Good job, guys. Okay, so I'm going to go over this. Looks like we're getting some answers. So this is where we start with f of x, or limit as x approaches -2 of that. First things first is we direct sub. Always want to check that first, because if we can direct sub and get an answer, our lives are made. Okay, so this is what we're left with. Well, we need to find f of -2. Okay, so we need to know what's in the numerator. So we got to prove it's 0 over 0. So we got to know what f of -2 is. To find f of -2, we're going to take 3 times -2. Oops. 3 times -2 plus the integral from 0 to -2 of g of t, which is equal to -6 minus the integral from -2 to 0 of g of t. Right, so whenever I want to switch the bounds, because the upper bound should be higher than the lower bound, in this case it's not, I can just put a negative out front. Look at your graph, calculate the area from -2 to 0, the area underneath that triangle, and you end up getting -7. So that would mean -7 plus 7 over 1 minus 1, which is equal to 0 over 0, which we know is indeterminate. Which means we use L'Hopital's. Take the limit as x approaches -2. And remember, L'Hopital's, you take the derivative of the numerator. So the derivative of f of x plus 7 is f prime of x, divided by the derivative of the denominator. Derivative of e to the 3x plus 6 is 3e to the 3x plus 6. Derivative of 1 is 0. So this is my new limit. I'll do some blue. I need to find f prime of -2, right? Because I got to do direct substitution. So I got to find f prime of -2, which is going to be equal to 3 plus g of -2, which is equal to 4. How do I find g of -2? Well, you just look at the graph at -2. What's the y value? Okay, and then direct sub. So I get f prime of -2 divided by 3e to the 0, which is equal to 4/3. Good job, people. All right, so that's the end of calculus for today. So I'll be back on Friday. Like I said, we'll review the homework assignment from tonight. We can go into detail. We got all Friday. So the whole stream, we can go over any questions you have from 2018. On Friday morning, I'm going to post the survey to figure out what you guys would like to see Monday. So make sure you guys fill that out. Keep an eye out for that. If you have any questions, I'll be here from 1 to 2 on my office hours stream. And then also, please feel free to email me. I'll answer any emails you guys have. All right, so AB, you guys have a great rest of your day. Appreciate you stopping by. You too, Emma. Thank you so much. Gentlemen, good morning. Algebra 2 people, how are you guys doing? You too, Brandon Gidio, thank you. Welcome, Algebra 2. Jade, I'm doing good. How are you doing? Thank you, Stack, and have a great day. All right. Algebra 2. What's up? How many people we got? So about 5? Morning, Gidio. So Algebra 2 people, go ahead and get 8.6 open up. We're going to continue with that chapter. Morning, Haley. So you Algebra 2 people, especially those of you who are in my first period know, I'm not much of a breakfast eater. So I've probably said that before. But yesterday, for whatever reason, I had some ingredients, and I was like, maybe I'll make breakfast today. So yesterday I made myself some breakfast. I made some sunny side up eggs, made some toast, had some fresh fruit. Really good. It was a good little change of pace. And I'm not a breakfast person still. Don't get me wrong. And that didn't change me, but it was nice because I didn't have to like panic and like rush to make my food. I could take my time. I got to eat it a little bit later. I don't like waking up right and the first thing I do is eat food, you know? It just bothers me. My body isn't ready to start consuming food. I just don't have any urge to. So I have to wait a second, you know? But yeah, so it's pretty good though. Today I did not eat any breakfast. I'm not drinking any coffee. Just woke up, took a shower, got myself prepared for the stream, got some water, and here I am. All right. So guys, page 572. That's where we'll be today. 572. Ooh. Actually, let me do this. Let's go here. Okay, so this is the page you should be on. Go ahead, guys, in the chat. Let me know when you're here. Go ahead and type when you guys are ready to go. Your notes are out, all set. Thank you, Jaden. Thank you, Aiden. Okay, so let's get started, guys. Let's first talk about what are we doing. So rational equations, solving rational equations. I'm gonna say it every time we're on stream. Rational expressions are expressions that include a polynomial over a polynomial. As with all of these functions that we talk about, all of these equations, it always comes back to the idea of that these can be used in the real world. That's why they're there. It's not just for fun, not just for the heck of it. It's applicable to the real world. And one of the equations we see in the real world is rational equations. So today what we're going to do is do word problems. We're going to go over word problems and examples of rational equations. So on 572, I'm just going to read this paragraph here. It says the weighted average is a method for finding the mean of a set of numbers in which some elements of the set carry more importance or weight than others. So that's called a weighted average. Many real-world problems involving mixtures, work, distance, and interest can be solved by using rational equations. Weighted average. Another place you guys might have heard this a lot is in school. Okay, I don't know how often this happens, but there's an idea of a weighted average for scores, for test scores. So the idea, like in standardized tests, do this a lot. I don't think AP does, but there's certain things that account for it. So like a weighted grade point average, right, is weighted because it means that you're taking into account AP and honors classes. So an AP and honors class is going to be worth more points than a normal class towards your GPA or your weighted GPA. It's making certain things more valuable, basically. So like for the GPA, they say, okay, honors and AP courses are harder, so we're going to put a weight to them because we got to treat them as if they're harder. So a B in that class would be worth like an A in another class, right? That's the idea of weighted average. I guess just stressing the importance of certain things. So let's go over this problem. This is going to be a mixture problem. All right, it says chemistry. So read along with me. It says Mia, or Maya, I don't know how she says it. Mia or Maya adds a 70% acid solution to 12 milliliters of a solution that is 15% acid. She's adding 70%. The solution is already 12 milliliters and contains 15% acid. It says how much of the 70% acid solution should be added to create a solution that is 60%. All right, so we have 12 milliliters of solution, 15% acid. We want to get that acid content all the way up to 60% by adding a 70% acid solution. So let's break this down. It says, understand, Mia needs to know how much of a solution needs to be added to an original solution to create a new solution. The plan. Each solution has a certain percentage that is acid. The percentage of acid in the final solution must equal the amount of acid divided by the total solution. All right, so this is an important, so this is number 3, important formula. So go ahead and write this down, guys. Percentage of acid is going to be equal to the amount of acid divided by total solution. Which makes sense, right? If I have 12 milliliters of a solution, 3 milliliters of that is acid, my percent would be 3 divided by 12. If 3 of the 12 milliliters are acid, then 1/4 is acid, meaning 25% is acid, right? So using this formula, let's break some stuff down. So percentage of acid. let's start there. I'll do equals. So in our case, the percentage of acid. That question is just saying, what do we want the percentage of acid to be? And if you look back to the question, oh crap, I forgot. Sorry guys. Silly me. Hopefully you guys still did it. Yeah, so all I did was write down the formula. Percentage of acid equals the amount of acid divided by total solution. Where did I get that formula from? Well, the book gives it to you, number one. But just, or moral of the story is we know how we can find a percent of something. It's the amount of whatever we're looking for over the total. So let's just start with the percent of acid. What's the actual number I'm looking for? In this case, it's 60%. And I'm going to write this as a fraction. So 60%, remember when we're working in algebra, we never want to work, we want to know percents, but we always want to change percents to decimals. Okay, in this case, I'm going to stick to the problem, how the problem does it. You don't have to do this. But at some point, I'm going to need to make a common denominator anyways. So I'm just going to keep 100. So a percentage of acid is going to be 60%, which is 60 over 100. So we're turning that percent into a proportion. All right, that's number one. Need that. Next part of this equation, I need an amount of acid. How can I find the amount of acid? Well, the amount of acid is going to be the original. So the amount of acid is going to be the original amount plus added amount. So AMT means amount. Just so you guys know, I'm abbreviating amount is AMT. The amount of acid that we have currently is going to be the original amount that we had to start plus the added amount. Well, the original amount was we had 12 milliliters total of the solution. And the acid was 15% of that solution. So it's going to be the same thing as 12 times 0.15. That's the original amount of acid we have. If it's 15% of 12 milliliters, that's 12 times 0.15. The added amount is going to be 70%, because when we're adding, it says Mia adds a 70% acid solution. So 70% of X. Right, because we don't know how much she's adding. So X is equal to milliliters of added solution. I'm just going to box these up just so I can separate them. Now you guys will see the actual book, they use tables. They actually use tables, which is fine. If you guys want to use tables, go ahead. I just think tables, I don't know, I don't like to look at them as much, especially because these tables are always going to be different. So I just kind of like breaking it down, and like I'm doing colors. So I'm breaking it down with colors. So we don't know X. X is what we're looking for. Well, not necessarily what we're looking for. It is what we're looking for. Yeah, it's exactly what it is. It said how much of the 70% acid solution should be added. X equals the amount of added solution. So that's what we're looking for at the end of the day. Okay, last thing we have to do, so let me just bullet point these. To get our final equation, we need the total solution. How do we find what the total amount of solution is going to be? Well, that's going to be equal to what we start with plus X. So what we start with plus what we add gives us the total amount of milliliters of just the total amount of milliliters in general that Mia has. And we start with 12 milliliters. So the starting total milliliters is 12 plus however much she adds. That'll give us the total solution. Now we put this together. So percent added is 60 divided by 100 is equal to the amount 12 times 0.15 plus 0.7x divided by the total solution, which is 12 plus x. Let's simplify this a little bit. I'm going to simplify this fraction to 6 over 10 is equal to 12 times 0.15 is 1.8. You can use a calculator for that. 0.7x stays the same, and then 12 plus x stays the same. All right, so no problem, Damon. Good to see you. Damon, we're on page 572. We're just doing their example, so you can just follow along. If you want to just copy it later, go ahead and copy it later. So I'm just working through their work. All right, so guys, now we work on what we did for Monday. So the homework that you had on Monday and the lesson that I gave on Monday, it's gonna take into effect now. And that's solving for x. I need to solve for x. I need to find what the milliliter of added solution is. How much did she add? So I'm going to start off with, you don't have to do this every time. I like to do it just so you guys know why I'm doing it, where I'm getting stuff from, is my least common denominator. In this case, I have 12 plus x is definitely one of my denominators, so that's got to be a part of it. And then 10. So 10 plus 12 minus x is going to be my least common denominator. Which means that the numerator of the left side is going to be 6 times x plus 12 divided by our new least common denominator, which is 10 times 12 plus x, equals 1.8 plus 0.7x times 10 divided by 12 plus x times 10. Right, so this first fraction was missing that 12 plus x, so I multiplied it to the numerator and denominator. I did x plus 12, but it's also 12 plus x. Those are the same. The right side was missing 10 in the denominator, so I had to multiply the numerator and denominator by 10. Now that I have common denominators, I can eliminate them and just solve what's left over. So 6 times x plus 12 is the numerator, equals 10 times 1.8 plus 0.7x, which is also the numerator. And let's solve. So I get 6x plus, so I'm distributing the 6. 6 times 12 is 72, is equal to, distribute the 10, 18 plus 7x. Subtract 6x to the right side, and I'm going to get just x by itself. Subtract 18 over to this side, and I'm going to get 54. Bam, 54 equals x. Nice clean number. Look back at the context of the problem. The question said how much should be added? How much of the 70% is acid solution? Well, that's going to be 54 milliliters. So our units on amount added is milliliters. All right, so go ahead in the chat. Give me some feedback. Okay, I don't know if you guys are ignoring me or um, maybe you're copying down the work still. I'm not sure. Oh, there's only 3 people in here. I didn't realize that. Man, I lost some people. Lost some viewers. Well, any of you 3 who are still here, if you guys would like to comment, be much appreciated. No? Okay. That's fine. Thank you, Jaden. Appreciate it. So, I want you guys to do the guided practice 3 on your own. And then type your answer in the chat. Thank you, Digidio. So guided practice 3 is Jimmy adds 65% fruit juice solution to 15 milliliters. That is 10% fruit juice. How much of the 65% must be added to create a fruit punch? That is 35% juice. Guys, this is the exact same type of problem. So everything we just did, you're going to do the same idea except with different values. So repeat the process we just did except with different values. Jaden, you got 45 milliliters. Not quite 45. All right. So we'll take a look at it. Okay, so let's take a look at this, guys. All right, so we have, I didn't do the outline like I did last problem. So let me just start here. Okay, so I didn't write everything separately, I just did it all in one. So the percent is just going to be, the question wants us to have 35% fruit juice, so my percent is 35 divided by 100, right? 35% is 35 divided by 100. The total amount, just the amount of fruit juice, fruit juice? Yes, so the amount of fruit juice is going to be 0.1, which is 10%, times however much we have in there. So this is just the beginning amount we have, is 0.1 times 15. That's what we started with. And then we're adding fruit juice at 65%, and we don't know how much we're adding. That's X. That's what we're looking for. So that's where we get this statement from. And then the total amount of solution in general is going to be what we started with, which we started with 15 milliliters of the drink. And then we're adding a certain amount of solution that will give us more, which we call X. So I know the only two that are answering right now are Sarah and Jaden. Did you guys get here? So did you at least get to that part? Okay, perfect, cool. All right, so we got there. Now we want to get a common denominator, or at least common denominator specifically. And so all that is just going to be the multiplication of the two denominators. So it's going to be 100 times 15 plus x. And then our new equation is going to be 35 times 15 plus x divided by 100 times 15 plus x equals 0.1 times 15 is 1.5 plus 0.65x, and that's going to be multiplied by 100. And then our denominator, or at least common denominator, is still there. So again, I was missing 15 plus x in the first fraction, so I had to multiply both numerator and denominator by that. And the second fraction, I was missing 100, so I had to multiply the numerator and denominator by 100. Now that I have the same common denominator, I eliminate the denominator and focus solely on the numerator. And let's start doing some math. So 35 times 15 equals 525 plus 35x. 1.5 times 100 is 150. 0.65 times 100 is 65. Subtract 150 from both sides. Oops. 525 minus 150, and I get 375 on this side. Subtract 35x from both sides, and I get 30x on this side. Divide by 30, and I get 12.5 milliliters. So my prediction then is, since you guys both got 45, somewhere with this least common denominator I think was maybe a mistake. So I challenge you guys right now, go ahead and tell me, because I can't see your work. Let me know where the mistake was. So this probably you guys both have the same one. Now you've seen my work and you got the first step, which is probably the hardest step, just setting up the proportion. Where was the mistake? This is a classic game of find your mistake, so Mr. Harris doesn't have to yell at you. Because you know me, if you guys make mistakes, I just yell. Constantly always yelling, telling you how you're always wrong, you know, that good stuff. That's how I roll. Ah, all right. That's what I was thinking too. I don't know why, but when I did that step, I think in my head I was like, oh, maybe they forgot that. So I'm guessing, yeah, so I got the same thing. All right. Good, so little mistakes, but that's okay. I can deal with little mistakes. Looks like you got the concept. Very good, guys. And whoever else is in this stream, I don't know who's here still here. Hopefully you guys got it as well. Let's look at 4. So 573. Let me get back to my book here. All right. So I'm going to need you guys to copy something down here. It says the formula relating distance, rate, and time can also be used to solve rational equations. The most common use is distance equals rate times time. You guys have probably heard that before. If you want to find the distance someone goes, you want to take the rate at which they're leaving, or the rate at which they're going, times how long it takes them. So if a car is going 20 miles per hour, and we want to know how far they are after an hour, they're going to be 20 miles, because they're going 20 miles per hour. However, it can also be expressed as this. So I'm going to write this at the bottom. We're going to call this distance problems. So you guys can title this section of your notes distance problems. All right, d equals rate times time. How else can we express this? Well, we can divide by t, which means distance divided by time equals rate. Or we can divide by rate, which means distance divided by rate equals time. So take a second, guys, copy those down, those formulas. That's what we're going to be using for the next couple problems. Because we know the general distance formula. To get the different pieces, you just manipulate it by dividing. And if you guys notice now, I have fractions. And when you think of rational expressions, you should be thinking fractions, right? So this would make sense why I could see how this could turn into a rational equation. All right. Oh, I'm sorry. I thought I was on my book again. Keep doing that. Stupid, stupid, stupid. So yeah, you guys can see what I did here. So I had distance equals rate times time, you divide by t, you get d divided by t equals r. D equals rt divided by r, you get d divided by r equals t. Just give you a second to write that down if you haven't. Okay, so we're going to look at number 4. Example number 4. So you guys can read along with me in your books. It says, Sandra is rowing a canoe on Stanhope Lake. Her rate in still water is 6 miles per hour. It takes Sandra 3 hours to travel 10 miles round trip. Assuming that Sandra rowed at a constant rate of speed, determine the rate of the current. All right, so they kind of break this down. So we are given her speed in still water. So no current, just still water, we're given her speed. And we're given the time it takes her to travel with the current and against it. We need to determine the speed of the current. So, here's what we're left with, basically. We have time with the current, time against the current will give us total time. So, essentially, we have time with plus time against equals total. Equals the total time. Okay, now here's the biggest thing that we need to talk about is how do we get the time with the current and time against and all that. So let's look at time with. Well, the time with is going to be, remember, we did this on the last page, time is equal to distance divided by r. So the distance divided by the rate. Okay, what's the distance? This is the tricky part of this question. What's the distance? Well, it's a 10-mile trip total. Total. If you guys remember, I'm going to show you my screen here. So if you're in a, like if this is your river, right? Water's not flowing this way and just like doing that. That's not how water works, right? The water is coming from a source and it's flowing one direction. So let's just say like the water's flowing this way. If your canoe is also flying along with you, if your canoe's going that way, that's going to be with the current. You're traveling with the current. Now you get there with the current, like this is peaceful, and you stop. And then you say, now I'm turning back, and you're over here. Well, the current's still pushing this way, and you're trying to go against it. So the current and you are meeting, and you're pushing against one another. That's how we're going to interpret this situation. So if this is a 10-mile round trip, that means there's 5 miles this way with the current, 5 miles this way without. So my distance with is going to be 5. Same with my distance without. Okay, back to my piece of paper. So you can see my distance is going to be 5. The rate at which you're going. So this is the time with the current. So if it's the time with the current, it's going to be 6 miles per hour in still water plus whatever your rate is moving, which we don't know. So we don't know what the rate of the current is, because if in still water it's 6, we're going to be adding the rate of the current, because like I said, back to my face, like I said, if you're going with the current, it's going to be, if everything's still, there's no current, you're just moving 6 miles per hour. But with that current, it's going to be that 6 miles per hour plus whatever this thing's pushing you. So the water's going to be pushing you, so it's going to be 6 plus whatever that rate is. Okay, so the time against is going to be very similar reasoning. Still going to be d divided by r. So the distance is still going to be 5, because we're going to turn around, it's round trip. So to get 10 miles, we have to go 5 one way, 5 the other. So the way back will be another 5 miles. The rate this time will be the 6 in still water minus the rate of the current, because you're going to be going slower. That current's going to be fighting your boat, or your canoe, her canoe. It's fighting her canoe, which means she's going to be going slower on her time against. Oops. The total time, I think it tells us, it takes Sandra 3 hours. So the total time is just equal to 3. So you guys can see now, that's the work I have. Time against the current is 5 divided by 6 minus r. Time with the current is 5 divided by 6 plus r. Total time is 3. Now we can set up our equation. So the time with is 5 divided by 6 plus r plus 5 divided by 6 minus r is equal to 3. Okay, so buckle in. I'm going to start flying through this now. Least common denominator is going to be the two fractions multiplied together. So 6 plus r times 6 minus r. Which means my new equation is going to be 5 times 6 minus r, because that's what I'm missing in the first fraction, plus 5 times 6 plus r, because that's what I'm missing, equals 3 divided by, 3 times 6 plus r times 6 minus r. Divided by 6 plus r times 6 minus r. Sorry about the horrible handwriting. Now that I have common denominators, I can get rid of them and focus solely on the numerators. All right, so let's distribute. I get 30 minus 5r plus 30 plus 5r is equal to 18 minus 3r times 6 plus r. So, Mr. Harris, where'd you get that from? I just distributed 5 to both of these, and then I distributed 3 just to the first set of parentheses, and I just kept 6 plus r by itself. Keep going. Simplify the left side. 30 plus 30 is 60. Negative 5 plus 5 is 0, so leave that negative 60. 18 times 6. I should know what this is, but I don't feel like finding it. 108. 18 times r is 18r. Negative 3 times 6 is negative 18r. Negative 3r times r is negative 3r squared. Simplify the right side. 18r minus 18r is 0. So I'm left with 108 minus 3r squared. Subtract 108 from both sides. So I'm going to get 60 minus 108. Negative 48 equals negative 3r squared. Divide by negative 3. And we get 16 equals r squared. So plus or minus 4 equals r. So looking back at the actual question, oops, sorry about that. Didn't get that last step. Looking back at the question, it says, determine the rate of the current. Well, the speed of the current equals 4. In this case, miles per hour. I'm putting my answer as 4 and not plus or minus 4 because your speed isn't, you can't have a negative speed. Speed is an absolute value, so it's always positive. So the speed doesn't have anything to do with direction. So the current, I don't care if it's moving with or against your boat, it's always going to be moving at 4 miles per hour. So that'd be your final answer. All right, so any questions you guys got, go ahead and type them out. Nope. Period. Attaboy. Jaden? I think. Well, I'll tell you what, Jaden. Let's put it to the test. So it looks like last time you guys pretty much almost had it. Everything correct? Let's try this time. So do real world problem, guided practice 4. So the number 4 is going to be the same idea as a current, except instead of current of water, this is current of the air. We call that wind. See what I did there? So guided practice is going to work with the wind instead of like a canoe and water. So go ahead and get started. When you guys get an answer, throw it in the chat. All right, so this will be our last problem for today, guys. See what we can do. Sarah, you're stuck? Okay. I'm going to start putting some stuff on paper. I'm not going to talk about it quite yet. I'm just going to start writing some things and check your work as I go, Judia. This actually might be, I noticed that I did something wrong here. So this is actually good. Tell you what, ignore that. Jaden got 6.6 hours. The question, Jaden, was not hours. The question was to determine the plane's speed. So you may be correct. I'm not really sure what you were finding, but we got to look for speed. So make sure you guys look at my paper right now. I'll talk about it at the end, but we should get to this point. Everyone should be at this point at least. So copy my work up to there. I mean, there really wasn't much work to show. That's just the total with wind, total against wind, and then total time in general. So based off of this, now I want you guys to solve for R. So even if you got stuck or if you got the wrong answer, I want you to go from here and solve for R. And then type what you get for R. Jade, you got R equals 2. So Jade, let me just ask you, would that make sense? Would your answer make sense? I guess that's my question. If it's asking for the plane's speed in air, would it make sense for the plane to be going 2 miles per hour? Now, I don't know what planes you ride, but I think you're gonna have a hard time finding a plane that goes 2 miles per hour in the air. So now I'm not saying that just to like, be a jerk or anything. I'm just saying like it's good because yeah, if you can think about if your answer makes sense, it'll tell you if you're right or wrong, or at least you have a shot. So you put that in the context of the problem, you'd be thinking, oh, I must have messed something up. Something had to have been wrong at one step. Because there's no way a plane's moving 2 miles per hour. All right, so let me continue. Let me help you out a little bit. So we got the time with the wind is going to be distance divided by the rate. The distance of each is going to be 1,184 because they go a total of 2,368 round trip. So split that in half, it's 1,184. Very important, the denominator. I messed up at first because the order matters. You want to take the rate of the plane is consistently going, which we're going to call R. The rate of the plane, the miles per hour the plane's going all the time. And you're going to add the wind resistance or subtract the wind resistance. So either we're adding the 20 miles per hour when we're going with the wind, or subtracting the 20 miles per hour when we're going against the wind. All right, so that's where these come from. Total time they give us is just 7. All right, I'm not even going to do the least common denominator part. I think you guys are okay with that. Maybe you guys have kind of seen this shortcut. If not, I'm just going to show you it so you can eliminate some of the work. I'm going to make a common denominator and then get rid of the common denominator anyways. So all I really have to do is figure out what in the numerator would I have to multiply to get all the common denominators, right? So the first fraction would be missing r minus 20. The second fraction would be missing r plus 20. And then the third fraction is missing both r plus 20 and r minus 20. So I have to multiply r plus 20 and r minus 20. Okay, now we got to do our calculator. So it's going to take a little bit of time for me here. So I got 1,084R minus 23,680 plus 1,184R plus 23,680 equals 7R plus 20 times 7 is 140 times r minus 20. Simplifying the left side here, I get 1,184 plus 1,184. That gives me 2,368R. Negative 23,680 plus 23,680 cancels. Distributing the 7R, I get 7R squared. 7R times negative 20 is 140, so minus 140R. Plus 140R. 140 times negative 20 is negative 2,800. Simplifying that, I get 2368R equals 7R squared. The R's cancel, negative 140 plus 140 cancels, and I just get minus 2,800. Okay, notice here, guys, I have a quadratic equation. So I want to set it equal to 0. So I subtract 2368R. I'm left with this. Now what I'm going to do, guys, is you could just use your quadratic formula. That would probably be the best option if you're going to do algebra with it. I'm actually just going to plug this into my calculator. So on my calculator, it's going to look like this. You guys would just use Desmos. Okay, but I'm plugging in that equation. I'm just going to look where it crosses 0. My window's not correct, so give me a second. Let me change that. So on Desmos, you'll just zoom out. It'll be much easier. On my calculator, I got to do a little bit more work. Sorry, guys. Give me a second. Okay. So you find where it crosses the x-axis. It should be at r equals 339.5 miles per hour. So that should have been your final answer. Okay, if you guys are still hanging out, let me show you. I'm just going to put it up in Desmos just because that's going to be something you guys will actually do. 0 equals 7x squared 2368x minus 2,800. Okay, so let me go to my screen here. Okay, so you guys would plug in the equation. You can see I put on the left. You can put y or 0. It doesn't really matter. We look at this value, and it's negative. The question is for miles per hour. It's not going to go negative miles per hour, right? The speed of a plane isn't going to be negative 1.1. So we're eliminating that answer. We want to look at the positive answer. That's where we get the 339.5. Okay, so that's all I got for you guys today. You're good to go. I'll be on from 1 to 2, as always, for my office hour. If you want to stop by, feel free. Hope you guys have a great rest of your day. I'll be here Friday for review. So any questions on the homework or Alex, please, or not Alex. Is it Alex? Can't remember now. Yeah, homework or Alex, let me know. I'll be here. So have a great day, guys.